Hello and welcome to the Terran Space Academy, where we help prepare you for a bright future in the space industry. This is rocket science, and today we will look at several concepts important to humanity's future in space.
No nation which expects to be the leader of other nations can expect to stay behind in this race for space.
There are several critical space technologies that may not be intuitive. One of them explains why I like space planes so much. When you are launching vertically, space planes don't make a lot of sense. It takes about 7 pounds down here to get an extra 1 pound up here into orbit. Sending up giant wings when you could just come down with a blunt capsule seems like a waste of mass, and it is. The space shuttle system was getting about 75 metric tons for the shuttle and about 25 for the payload into low Earth orbit. 100 metric tons. But 75% of that didn't stay in space. And while it was reusable, the cost of reuse was much too high. Some would say that you're building an airplane and throwing it away when you use disposable rockets, but you don't have to. Two separate systems, one optimized for safety that carries people, and one that is optimized for cargo that carries a lot of mass, would have made a lot more sense. Scientists knew this, and companies like TRW, Aerojet, and the Aerospace Corporation were proponents as early as the 1950s. These would use steel structures and pressure-fed hypergolic or RP-1 LOX engines with simple pintle injectors and what some called a big dumb booster. The ultimate design for this was the Sea Dragon. Then TRW became Northrop Grumman and developed the high-power, low-cost TR-106 rocket engine. This engine produced 2,890 kilonewtons, which is about 290 metric tons of thrust. They also designed a low-cost booster to get 25 metric tons to low Earth orbit, matching the space shuttle but costing only $59 million per launch, instead of the over $1.5 billion that the shuttle ended up costing. The concept for human transport would be a winged ship optimized for safety, starting with the Dinosaur in the 1950s through the HL-20 of the 1990s. Nothing that lands vertically will ever be safer than a gliding lander. But politicians would not fund two different systems, and this forced NASA to make a change in the cargo and crew-carrying shuttle, combining them into one. While this was a beautiful example of extreme engineering brilliance, it was not sustainable, and in the end, a terrible mistake. At the end of the Apollo programs, we could get something as big as Skylab into low Earth orbit in a single launch, and we could use the Saturn 1B to fly crewed orbital missions. Or, if we needed to get to the moon, the Saturn V. We lost all of that, so we could get only 27.5 metric tons to orbit, at an exorbitant cost. The Chinese do the same today for about $70 million, with the Long March 5. We could launch 20 times more mass for what the shuttle was costing. But we didn't, and a lot of space engineers got discouraged. One of them was named Tom Mueller, and you know the story. Having worked on the TR-106 engine and seeing it canceled, he retired, going into the desert to build giant model rockets. Elon Musk went to find him to build SpaceX a rocket engine, and the rest is history. Today, there is nothing close to matching the SpaceX Falcon 9 Merlin engine for dependability or cost. Starship is the realization of the other goal. It is not really a big dumb booster, as it uses one of the most sophisticated rocket engines ever designed, matched only by the shuttle main engines and the Soviet RD-270 perhaps. The Blue Origin BE-4 is not as revolutionary, having an oxygen-rich preburner more similar to the RD-180. But none of that matters if something works well. The Vulcan rocket system will have its second launch soon. Assembly was completed on the 21st of September, and it's scheduled to launch on the 4th of October from Space Launch Center 41. This launch will be somewhat wasted with a dummy payload, instead of the intended Dream Chaser spacecraft. Dream Chaser is the intellectual child of the HL-20, but was designed just for cargo when Starliner was selected instead for crewed flight. A decision that will go down in history as a massive waste of taxpayer dollars. A design like Dream Chaser is the ultimate lifeboat, able to glide safely to a landing almost anywhere on Earth at any time. But why do I like spaceplanes so much? Here's why. While launching a large winged vertical vehicle is not optimal, because a vertical launch requires a thrust-to-weight ratio of 1.5 for one thing, and requires a lot of force, which means a lot of engines, which means a lot of mass. On the other hand, horizontal launch has a lot going for it. The Boeing 727 has a maximum takeoff mass of about 78 metric tons, almost exactly the same as a shuttle. But its thrust-to-weight ratio is only about 0.22, 7 times less. That's the power of lifting surfaces moving through a thick enough atmosphere. So launching a large winged vehicle vertically, like was accomplished with the shuttle and the planned with the X-33, makes little sense. The second thing about spaceplanes is whether they are air-breathing or not. If they only use onboard oxygen, then you must carry enough with you, and you lose a lot of the advantage of winged atmospheric flight. Now, most of us intuitively think that you must go up to get into orbit, but what's really important has much less to do with vertical than it does horizontal. Only horizontal velocity matters when it comes to staying in orbit, and you could go fast enough while using atmospheric oxygen, if you could withstand the heat, to reach orbital velocities. If this were possible, you could have a much more compact, more efficient, and safer system. But still, pure horizontal launch rocket systems like Star Raker, while amazingly designed, were not optimal. Radiant Space and Dawn Aerospace would disagree, as they are actively testing rocket-only spaceplanes. Polaris spaceplane from Germany is using air-breathing engines at much lower speeds, then switching to a linear aerospike to boost into space. But air-breathing, I believe, is the way to go. Several air-breathing horizontal launch systems are expected to reach Mach 10 within the next year. That's about 2,950 meters per second at just above 10,000 meters or 35,000 feet. This gives you the same performance as the entire first stage of a vertical launch booster. If you could continue air breathing up to Mach 26, you could use a little onboard oxygen to boost on into space. But anything at or above Mach 10 makes this the most efficient and safest way to get to space. You can circularize your orbit and complete your mission with regular rocket engines. Then safely glide to a horizontal landing. This is the Cochrane exploration concept. Maximum safety and reusability. We will see all of these systems flying soon, and eventually, going into space will be as simple as going to your local airport, where you will take off like any other plane, but fly on into space and the orbital habitats there, transferring to longer-range ships that can take you on to the Moon, Mars, Mercury, Titan, or even Callisto and beyond. On these journeys, humans will need artificial gravity, and for the really long flights, probably some type of hypersleep. But hypersleep can leave you with wasted muscles, unless you have some way to stimulate them without activity. When muscles exercise, their mitochondria release signals that generate all of the restorative effects of exercise. It turns out that mitochondria can also be stimulated by deeply penetrating low-intensity pulsed electromagnetic fields. I am currently consulting on the evaluation of one of these devices. Double-blind placebo-controlled studies show that just 10 minutes in this device can mimic a week's worth of regular aerobic exercise. This will be critical for health during missions to Mars and beyond. Massive interplanetary colony ships will require massive vertical launch rockets like Starship to get enough material to orbit to build those orbital habitats and space cruisers. There are many ways to get the job done. The only question is which flag will these ships be flying and when will it be accomplished? As most of you can imagine, in light of recent events, I am not pleased with some of our choices here on Earth. Powerful governments and police systems keep you safe from criminal elements, but leave you defenseless if targeted by those in power. That is my greatest fear with Elon Musk. I have great admiration for what his companies have accomplished. But it's important to remember that he personally has invented nothing. He is efficient at raising money, assembling and inspiring a team, and accomplishing the mission, if quite a bit later than he says it will be. This is still a rare and critical skill, but he's also prone to overselling and saying outrageous things, which can get you into serious trouble. SpaceX, Tesla, and Neuralink would continue without him, but his dream of Mars colonization in the next 2 decades, unless someone with the same skills and resources steps up, would be dead. Bezos is much more conventional, and his dream is to have orbital habitats and lunar colonies. I think he'll get this accomplished within his lifetime, which is about another 3 decades unless longevity technology improves. And it is, rapidly. Those of you who think that you will be too old to see or benefit from these advances need to hold on a little longer. There are human trials I want you to watch. One uses custom-made antibodies to block Interleukin 11, because it turns out the human body does not wear out so much as it receives a signal to start aging. These signals occur at about 40 and 65 years of age, and the signal seems somewhat continuous, with Interleukin 11 levels suppressing restorative properties of stem cells. Blocking this pro-inflammatory chemical signal slows and even reverses signs of aging in mice. Now we're looking to see how well it works in humans. And there will be a link to the Nature article in the description. The other regenerative technology to watch was developed at Harvard with help from MIT and the University of Maine. This brings us to stem cells. These supply all of our healing and restorative new cells, but around age 75 they start to shut down. Then scientists discovered Yamanaka Factors. These 4 transcription factors can reprogram adult somatic cells back into a stem cell state, resetting the clock and reversing signs of aging in animal experiments. And human trials are being planned. Telomeres are repeating DNA fragments on the end of chromosomes. As the cell divides, these ends get clipped. Babies have an enzyme that puts those ends back on, but once we reach adulthood, that enzyme is turned off. Otherwise, we are highly prone to developing cancers, which reactivate this gene through mutation on their way to malignancy. Scientists started looking for ways to safely get around this limit, and using targeted viral and artificial vectors, can now reactivate this gene only in the cells needed, resetting the aging clock in important stem cell populations. All of this means that functional human immortality is not an impossible dream. We will need to develop social systems capable of dealing with these realities. And this can be a problem. We don't even have a social system capable of dealing effectively and humanely with our current reality. What will we do when the rich and powerful are also immortal? For one thing, we will need new frontiers to expand to, so that we can build new societies and test new systems and have the freedom to explore. The United States was possible because it was far enough from Britain's power to try things that would never have been allowed in the empire. We need the same thing today. Somewhere to go to get away from stultifying regulations and over-policing. Somewhere that our children and their children can make into something greater than we can imagine. That is my dream, and I hope to live long enough to see it with my own eyes. I hope that many of you will be there to see it with me. Thanks for listening and for your support over these years, and stay safe. At Astra Pro Terra. Why do so many of us look to the future? A huge amount of creative energy is spent by brilliant, talented people trying to convince others that space exploration is important. Why do we think that advances in technology are important? And why should the average person care about space? Futurists are those who imagine human civilization not as it is, but as it could be. To paraphrase Robert Kennedy, some look at the world and ask why. We look at the world and ask why not. Human beings are capable of incredible technological advances and incredible destruction. Governments will spend trillions of dollars to develop technologically beautiful machines, then use those machines to bomb cities. Most futurists are optimists, even the angry astronaut, I suspect. But loving science and technology means you must, above all else, accept the truth. The truth is that there are over 7 billion people on this earth. If everyone lived to American standards, we would need the resources of at least 5 Earths. But we only have one. If we assume that life is a zero-sum competition, that the poor have less by choice alone, that those with more deserve to eventually have all, and those with less deserve to eventually have nothing, then this world will end one way. Human beings do not go quietly into the night. We have wars over football games. We riot at injustice. And our technology has made us capable of ending everything for everyone on this planet. There is not a nation on earth that does not have blood on its hands. And there are no societies on earth that cannot put everything aside for the future of their children. If you believe that everyone on this planet has the right to an equal chance of fulfilling their potential, to live in security, with opportunities and an unlimited future, then join us and look beyond this planet. Governments may not always make the right decisions, but visionaries can lead us into a better future. Those of us who are grown will have to dedicate ourselves to developing the technology and infrastructure necessary for the next generation to have this choice. Humans have put aside their differences in the past to defeat tyranny and accomplish great things. We must do so again. Some of us will die in this endeavor. From radiation, from the effects of low gravity, in accidents. There are always a million ways to die on a frontier. But if we persevere, we will build not just the cities on the moon and Mars, but further out into the solar system. Even if the next several generations never develop the technology to go to another star system, we have more than enough resources in our solar system to sustain a population of hundreds of billions. And by moving some of us off the Earth, we will save the Earth itself. Then maybe our descendants will look to the stars and say, why not?